Hi, it's Gadget UK here again, back with the CD32. So, a huge thanks to Stefan in Denmark. Did I say Sweden in previous videos? He may be on the border between Denmark and Sweden, but anyway, I think he's Danish. Yeah, Amiga CD32, he sent me 2 of the FMV modules, so they're kind of in pieces at the moment. He already sent them that way, you know, he's obviously had a look at these, I think, or someone has. So yeah, we've got 2 of these things here, 2 PCBs, 2 of the shells. Not got any screws, I don't think, so yeah, that could be an interesting one. This one's obviously missing the BIOS there. So yeah, first inspections of these boards, one of them, I think this one, has had a lot of rework. All of the chips up here, like they've been sort of swapped or something. There's a crack on one of the caps here, I'll show you that in a minute. I noticed that straight away. The cap on this one's okay. And this one, I don't know, I don't think this one's been tinkered with. Could be wrong, it might be this one. No, hang on. Yeah, I was going to say, I think it's this one actually that's had the chip swapped, and this label here was like peeled up as if it had been affected by hot air. I see some flux around there. But first of all, I thought I'd like to try and test these to see what they're doing. Now the problem is, because they're not in the shell, they're going to sag down and short on the shielding. So you know what, I'm going to have to tear this down, I think, right at the start here. I'm going to need to do that probably in order to be able to even access them and measure anything actually in the circuit. So we'll get the screws out of the underneath of this, carefully disconnect the ribbon for the drive. May need to short the lid detect thing, because there's a thing, isn't there, there's something there that resets it when you've got the lid open, if I remember. This, you know, it's like one of the cables that comes off here. So I mean, you could just disconnect that and plug that in. I might end up doing that, I don't know, but I might be able to just bypass it with a Japont or something. So yeah, this CD32 needs a recap, so that's going to be in the follow-up video, I think. And I've also got a TF360 from the amazing Mr. Terrible Player, Stephen Leary. Yeah, so I'm looking forward to building that. So I'm just going to be extra careful here, just to avoid scratching the lid. I think there's 5 screws, and there's one at the centre here, and then the corners. So adding this bit at the end, what is video CD? It's a format and a media combined, really. You know, it's a CD, compact disc, and you can put a video on it. Yeah, typically you got 2 discs with these, because a CD, you know, what do they hold, about 680 meg or something, 700 meg roughly. You could get 800 megabyte discs. I'm assuming there's 2 discs. Yeah, there is. Yeah, most of these were split for that reason into 2 discs, because many films are more than 74 or 80 minutes, aren't they? So I've got a few different ones here. I've got the original Naked Gun, the second one, the third one, and In Bed with Madonna. Yeah, it was more popular in Asian countries, you know, like Japan. It was super popular in Japan, I think, video CD. There was quite a bit of support for this platform in the 1990s. It came out in about 1993. It was created by Philips, Sony, Panasonic and JVC, I think. And there was, yeah, quite a lot of support in the West in terms of different players. You had things like the Philips CDI, the later 3DO would do video CD, I think. You may have had to have a module or something on the back for some of these devices. In fact, you did with the Philips CDI as an FMV module, just like this, that you would plug into the back of the CDI. Certainly the earlier ones. The later ones may have had the MPEG decoder, because that's what the compression format of the data on these, the audio and video, is MPEG. And MPEG, if you're not familiar, is Motion Picture Expert Group. So the video CD format used MPEG 1. Now, if you know anything about DVD, that uses MPEG 2. And then obviously later you've got Blu-ray, which uses other, I can't remember what it is, I'll stick it top left there, other types of higher compression, you know, higher bit rate and stuff, and you get better compression. So yeah, video CD was an improvement on VHS, as I've mentioned when I covered the CDI stuff, but the downside to it really was the having to swap the disc over halfway, and that's one of the reasons I think it failed. It didn't really pick up here in the West like it did in Japan. Without further ado, let's try and lift the lid. Now, if memory serves, the flat flex is right on this side here, and you can sort of lift and, yeah, hold it like that. But then you've got to somehow try and lift the plastic hood up when it's tucked down there like that. This is where pliers would help, and I'm not even sure if I'm going to be able to get pliers in that gap. There we go, it's come off now. Flat flex can come out. And I can disconnect that there. This is where we may need a DuPont or something just to trick it into booting up. The ribbon edge there all looks alright, but those can fold up pretty easily. Yeah, so at this stage you don't need to get the shielding off further. We do need to do something here to get it to boot, I think, because it's going to think, mind you, it might power on alright. I think it may just think the drawer's open. That might be what happens, and obviously we're not bothered about the disc just at the moment. Yeah, and just for now I've just connected the 3 composite connections on the back, just in order that we can actually get some video output. So yeah, we don't need the drive at this stage, or the switches and things, you know, that connect to that little JST connector. I fell behind the chair there. So yeah, first PCB is in there. We need to just simply try and align the connector on the back there and push it into position. It feels really spongy, that. Anyway, now just to make sure there's no chance that this is short, and do you know what? I think I'm just going to just wedge the plastic of the handle there, like that, and let's just sense check. Yeah, power it on. Now we do have video. The question is, how would you know whether the module's doing anything? So from the start here, I didn't do any research. I wasn't familiar with how this unit should work, the FMV module. You know, did you need a disc in there or not? And it turns out you do need a video CD in. So I fast forwarded through all this initial testing here. It was just coming up with, as you can see here, the sticker disc in screen. It wasn't really doing anything. I then swapped over to the other board. The ROM wasn't fitted there, so fitted the ROM and tested doing just the same thing. So I came to the conclusion it must need the disc in the drive. So yeah, I'm just going to put the wrist strap back on while I just finger touch some of these things. So let's just switch it on. Look at the screen. Yeah, it's booting. So this is the other board, obviously. Obviously it's missing the ROM, so that's not going to do much, is it? Anyway, it's just the same. So let me get the BIOS on. So Stefan kindly provided this in here. So pins look nice and straight. This one's 40.28. I think the other one's 40.28 as well. Yeah. It's like the ones on the 500 Plus where the socket's bigger. So yeah, it's aligned to this side here, the right side. So you've got a gap at pin 1. Right, so a lot of cursing later and swapping boards around with the BIOS. One of them is doing something. This one doesn't do anything. The one that's had lots of solder work on it. This one, as you can hear, is clicking and squeaking. I can only show you a second or two of that because it's copyrighted. You can't really hear the sound there, so there's no chance of a content match on that. So the question is it struggling to read the disc? Because you know what? It's had a new laser, this, hasn't it? So it should be alright. But my point is, I don't know, it took a while to start. It had a few, you know, it started flashing a bit. And I'll show you actually, let's just power cycle it. It's just to stop the disc. And you can sort of see how long it takes. And I'm just not sure if this is normal, so watch the laser. And in fact, the first power cycle, it took ages to actually come on, which is weird. Could be the reset circuit in there. So it went off, see? Then it goes on again. I'll tell you what's on the screen, nothing, man. Still black. Off. And a minute. On again. See, this is the thing, hang on. And then on, off. And then I think, there you go, starts to stream. So is that normal? I don't know. If I was to hazard a guess what's going on here, it's sound related, clearly. The video is rock solid, crystal clear, stable, etc. Which makes you think about audio decompression. There could be separate RAM for... yeah, there probably is separate RAM for audio decompression and RAM for picture decompression. I mean, if we have a look at this card here, what have we got? We've got a RAM here. We've got a RAM here. So yeah, I'm thinking could be one of those. I would expect the smaller one, to be for audio, but you know what? That looks really tiny. I don't even think that is for audio. Let's just look at it. Yeah, it's an 814256, so that's pretty small, but then again, it doesn't need to be that big. Could also be a DAC problem, maybe. How long we got a green as well? Let me show you. See the picture's green? So yeah, I saw this on RMC's channel. I've seen it before on forums and stuff. Probably capacitors, I think. Or it could be the DAC, video DAC. But I'm thinking the squeaks could be an audio DAC problem. So yeah, multiple issues for sure. And obviously this board doesn't work at all at the moment. Anyway, it's quite entertaining watching it all in green with the squeaks and clicks. Yeah, copyright content match blocker here. Just thinking out loud here, the picture is solid, which means the CD read speed is correct, you know, the 150k per second that this drive needs to do for video CD isn't an issue. So yeah, it's just the audio decompression and that colour issue with this particular one. So I think I may just start on the colour issue, and I'll just blitz the, well, I'll measure first, but blitz the three caps, and I think they're here, one for red, green, blue, I'm not sure which one's which. We've got a cracked cap on this board here, so, you know, maybe the same sort of issues happened over there, but yeah, we'll just measure, I'll measure on resistance, so that one of them has turned into a resistor. So I've looked at the schematics, I'll show you that in a minute. This is the RAM for the sound side, this is the sound decompressor. It's going to be handed the data via serial, probably from the main MPEG chip there. This I think is for the video side of things, but anyway, just inspecting around here, and I noticed this very early on, but I didn't point it out. Yeah, there is a green mark here. Someone marked that to say there's an issue, or I don't know, is that, I might be seeing things, I don't know. But anyway, yeah, so I'm going to get the fiberglass pen onto that, clean up the surface, unblock it I think, because I may have solder in it, and push a piece of Commodore through to the other side and then solder it, and then retest, see if the audio comes back. Yeah, so on first inspection this FMV module can look complex, but it isn't really. There's not a lot on there, and it's quite simple the way it's laid out. So this is the main MPEG chip here, the CL450 U200. And you can see we've got some connections here to U210. This is the video DAC. We know this because you've got red, green and blue connections coming out here. You can see you've got analog blue, AB, analog green, analog red. In fact, those are inputs from the CD32. So it looks like this chip here is merging the red, green and blue from the CD32. Yeah, and then we've got AR-Xed, analog red external, so that goes out, analog green Xed and analog blue Xed. So yeah, it's quite simple. In terms of coupling, and this is where you're going to get colour problems, it's going to be, you know, one of these caps here, so that's 0.22, yeah, it's 220 nanofarad, 0.22 microfarad. There's one there on the green and one on the red. So those three caps, and if you saw the RMC video there, where Neil and Mark looked at CD32, and it's been pretty well documented this. I've seen other people talking about this in the years gone by. The caps on here, the ceramic caps, not necessarily electrolytic ones, but the ceramic ones, the electrolytics leak, and I think Stefan has already recapped this. I'll talk about that later in the video, because I think they're a bit high, the caps. Height, you know, physical height, they need reducing a bit, because the next lid won't fit. The other thing that could be going on here is the resistors. You know, if you had a problem with one of these resistors somewhere, that could cause an issue as well. And of course, the actual video DAC itself could be the issue. But the fact we have colour and then we get like a green tinge, I suspect it's going to be one of these ceramics here. Right, I'll show you in a minute up close, but I found a broken trace on the negative side of that cap. Yeah, the three common ones for the colours here, these ones. I've tested these with the ESR meter, and they're all good. And I think they've been swapped. They kind of look like they've been swapped to me. We can recap this if we need to, but anyway, I'm going to swap, as a precaution to the colour thing, swap all three of these ceramics. And again, I've measured these in circuit using the Peak LCR tester, and they're okay. So I'm just going to get a little bit of solder and use the iron, just rather than hot air, just use the iron to drag these sideways. And then I've got some brand new ones here. They're the exact right length, they're just a bit narrower. but the super high quality ones, so they should be alright. So I'm going to put it back in a sec. So yeah, a little bit of solder on each side, and just heat the sort of two sides together. There we go. A bigger chisel tip. Hang on, it came out and then it sucked itself back. Yeah, a bigger chisel tip would be better. I just tapped that onto the bench there. I'll just do all three at the same time, right? Just change the angle slightly there. We'll just get a wee bit of flux onto each of those. Just helps to dissolve the braid. There we go, it's one. It'll be further down the braid, I think. There we go. I'm going to just lob those three on there. Yeah, I've just rotated the board a bit there. Hopefully that's not going to blur. Yeah, as I say, if these aren't quite straight, I am not too worried. The key at this stage, just to get them on. And yeah, I do have some tweezers, so I could be, or should be, using tweezers. Yeah, so we'll straighten up in a minute, just making sure those are on, and they are. The main thing is I just want to test it and see if that solves the problem with the colour. I don't think the fix the cap it here is going to make any difference to the audio. I think with the audio, we've got a problem with this chip here, problem with connectivity, or it's RAM. Right, so this is what I get for working late at night when I'm so tired. I've swapped the wrong, the cap's on the wrong board. This is the board I was looking at. This is the one where I fixed the cap there. It's not made any difference to the sound. This cap here, if I just put the points on here, I'll show you the meter in a sec. A minute ago, it's showing 7 ohms on that cap, which is a bit weird. Could have just been some flux. It's showing alright, you can hear it going ding ding. I'll show you in a sec. Yeah, I'm just going to just test these three caps again with the other tester, because this one here for ESR can't really test ceramics with that. It's designed for electrolytics and tantalums and things like that, you know, sort of things over, I don't know, 0.47 of a microfarad, that sort of thing, probably. Might go lower. Yeah, so using the LCR meter here, this came from the Ellison Charles actually. Yeah, I'm sorry you can't see what I'm doing here. Yeah, you can see an approximate reading there, 274 nanofarad. So, I don't know, it's mysterious. The thing I would say as well, you've got to have the positive on this meter on that side, otherwise it measures as a resistor. So, I mean, in terms of the meter, it's sort of showing alright, but we know these are alright, so, you know, I'm going to swap these anyway, just like I did on the other blooming board, and yeah, we'll give it a try. Right, that has solved the colour problem, I think, because the key was, when it was fading in between scenes and things, when it goes black, it was like green. Now it's not. So yeah, one problem down, just the audio issue to do with on this card. Yeah, so thinking about this audio issue here, you've got the L64111 here, LSI Logic. So that's the, I don't know if it's 100 pin, isn't it, quad flat pack, which I suspect is doing the decompression of the audio. You got MP1, MP2 audio. So I need to have a look at the data sheet for that. I'll do that later, I think. So it's got 3 connections here that go to the DAC. This is the audio DAC. Yeah. So the audio DAC could be the issue. Out of the audio DAC, you've got left and right audio here, and then some op amps. Yeah. And obviously your audio outputs that go to the CD32 and get mixed with the normal audio. So it's very unlikely to get pops and squeaks from this section here. Now I know this because my prior experience dealing with MPEG, and you'll know this if you've ever had video CD from back in the day, you'll note that if you get like, I don't know, a knock the unit, or if you've got little marks or scratches or dirt on the disc, a fingerprint, you get, in terms of sound, you get pops, squeaks, clicks. Video, you might get blocks, random coloured blocks appearing in different places, the odd artifact, etc. So those sort of problems you can get with problems reading the actual disc, you know, before it gets into this decoder here. But it could also be this decoder. The other interesting thing is, look at this corner here. So there's the same chip again, L64111, and you sometimes find this if you're looking at schematics. You know, you've only got a few connections here. You may think, is that all that chip does? Just has these connections and that? That's not a lot. Check the other pages of the schematics, because the logical functionality is separated into different areas, and that's what we got here. The RAM side of this L64111, it's got a RAM there, and we looked at that a minute ago. That's going to be the first thing I'm going to consider swapping. I think it's more likely to be this, but it's 100 pins. I really don't want to swap that chip between this board and the other board. We don't know the state of the one on the other board, so that would be a recipe for disaster. I mean, you could just argue the same with the RAM, but I think I've got a spare RAM. If not, we'll just borrow the RAM from the board that's not booting at all. Yeah, so it's 256K by 4. So yeah, from memory, it's the same chip type, although it's in a SOJ package that you get on an A500 Plus. I fitted 4 of those onto an A500 RAM board. There'll be a link up there for that. So I think I've got none of those spare now, but I'll check. I'll just check I've got some, if I've got any first, and if not, we can pull one off the other board or off the GVP. Yeah, so it's 4 data bits. I think those are at the bottom there. Address bus, 8 or 9 address bus bits there. RAS-CAS, write enable and output enable, or something like that. So dead simple. And we can perhaps scope that maybe as well. But in general, the pops and clicks and stuff and squeaks, I don't think it's going to be the DAC, but you know what? It could be. This is a digital interface as well. And I might just swap the DAC if the RAM doesn't solve it. Just because it's easier to swap that than that quad flat pack 100 pin decoder IC. And the other thing I may do before I swap the decoder IC is this 22 picofarad cap here. I mean, I could scope this. It's not the easiest thing because I've got to have the lid sort of down in order to read a disc properly. But yeah, I might scope this clock here. We've got a 16 point something megahertz clock here that feeds the DAC. If there was some jitter or something on here, maybe we could get that sort of thing, but I don't think so. I think the way the sound is glitching is kind of pointing to the decompression side of things. So an interesting thing just happened. I was playing a video and then I smelt something burning and it reset. It's that cap. It's the same as exact same cap that's happened to the other one. I actually think the caps on these turn into resistors, and then that's the problem. So we might need to swap the ones that look the same physical size on this, because these 3 fix the colour. So yeah, I need to now remove that because that's kind of like shorted, I think. Right, so I removed that cap, and thankfully it didn't kill the CD32 or the FMV unit. Yeah, that's really weird. It was quite charred, the board as well. It's going to need a bit of clean-up work, that now. And yeah, just having a think about this popping and squeaking. It's quite relaxing, actually. It sounds like water. I actually think this, what we're hearing here, is an audio decompression artifact. Yeah, so this LSI chip here does the audio decompression, but it uses this RAM, and then it outputs the DAC. Now, the other possibility I did consider here, the ceramics, you know, the ceramic on the board that's in there at the moment here is balked, you know, blasted apart. Oh, sorry, this one here, not that one. Blasted apart. So I've replaced it now. And these 3, those need straightened up on this board here, were an issue. Well, one of them was with the colour. So the other possibility is maybe another ceramic. If this, I mean, it might not even be the same size. You know, this one's 220 nanofarad, you know, 0.22 microfarad. There are some 22 picofarad ones on this board, and there's obviously an awful lot of caps on the underside. I'm thinking one for a crystal for this, maybe, because if you had a tiny bit of jitter on here or something like that, if it wasn't just quite right, the clock to this, in theory the decompression could be glitching a bit. So you know what, it could be a clock thing, actually. The big problem is, how would you scope it? This is the thing. I'd have to take the neck out of here, support it away from the shielding, do something with the, you know, the I don't know, the lid sense thing. The JST connector under there, it's just really fiddly to work on. I don't like working on things like this because of that, you know, the awkwardness of it. I think what I'm going to do is just go and compare this board to the schematics, and any of the ones that look the same sort of physical size as that one. There's like one here, there's one there, there's one there, one here. I mean, they're probably just on the main supply rails here. Swap them out. So I'll show you this on the scope, and I'll try and highlight on a diagram some of which pin. So this is pin 1. You see that? We've got a problem. We've got a logic level problem. I think this is the address lines going to the RAM. When I say RAM, we're talking about the audio RAM here. If I do a run stop, you can see these weird peaks. This is the problem, I think. The addressing is balked. Now, because it's not pulled, it's not going high, maybe we need to just pull it high or pull it low. I don't know. I'm going to try. Anyway, so that's pin 1, pin 2, same problem. Pin 3. Looking normal. Pin 4, looking normal. Pin 5 is not used, I think. And then on the other side, so this is the furthest from the, you know, this is the end pin. Nothing there, the one next to it. Balked again, logic levels. One next to that, balked again. The next one, okay. So we've got like looks like 4 address bits, I think, there, because I think that's what goes on that side, unless that's the data bus. In either case, could be the data bus actually. These could be address bits over here. I'm going, you know, on the same side, furthest away from pin 1, almost at the other side of the chip here. These are all looking fine. So you know what? One of the buses there, either the address bus or the data bus, and I'm thinking it could be the data bus because we've got 4 pins, just look really messy, didn't they? If we can clean that up with some pull-ups, pull-downs, maybe the glitches will go away. Might actually be able to fix this. Yeah, so just pausing it there. The audio goes away, but you see there is a mute capability on that chip. It can send a mute, I think, a mute signal. So it may well be that it's muting the audio, which means the DAC is not getting anything. But if it doesn't do that, and it just keeps feeding, you know, like as a quiet level to the DAC, that would show that the DAC is alright. But I suspect it's probably muting the DAC. Because it goes suspiciously quiet when you pause it. Yeah, so I'm going to continue looking at the ceramics just to rule those out. But then I think I'll swap that RAM, that DRAM, because I've got some of those as spares. Yeah, so I don't think it's going to be another ceramic unless it's one of the 22 picofarads, but they're a different size, and there's probably going to be a reason why these ones here failed. The 12 volt supply feeds into those. You know, you get cap problems somewhere. In theory, yeah, it could cause some sort of failure. Ceramics, those ones seem to be more prone to, you know, shorting. So I'm just going to try and heat this up. Almost there. Just lob that off. I've got a wee bit of flux on there, use the desolder braid and get a new chip on. Right, so swapped that RAM out. I didn't have a brand new one, I had to take one from the GVP, which you saw hopefully in the previous video. So it's not the RAM. Oh, that's not good news. So, oh, what a pain. It's going to be that LSI chip, isn't it? I guess the next obvious thing is the DAC, because we obviously had a supply problem, I think, on the 12 volt side, which may cause problems with the 7805 on the DAC side. Maybe it had some latch up type issue or something. Right, so what's the audio DAC? I know I haven't shown you that, but there's going to be an opportunity on the next board to do a bit of assembly work. If this doesn't work, it's going to be the LSI probably, unless it is just a clock thing. I really should go and maybe check some of those caps on the crystals and things. There we go, so it's not the DAC. Oh, that is so annoying. It's really annoying when it's a custom like that. I mean, in theory it could be the main MPEG decoder chip there, because that's what, you know, takes the data packet, if you think about it, you know, like the block of data from the optical drive, and then it's splitting it up into its constituent parts of video and audio, and it hands over the audio to the LSI to do the audio decompression. It's like MP1, is it, or MP2, I think? Yeah, predecessor to MP3. But yeah, trying to get those customs is pretty much near impossible these days. Right, I guess what I should do really is swap that. But yeah, I'm stabbed in the dark here, educate guess. Can you see here the pins on this look dark? 3 pins there. Yeah, this passes some signals for this chip, presumably to the lattice. So you never know, it could be that, but these look like they've all been swapped, but we don't know where from. Maybe they just got reflowed. So yeah, I'm going to swap that. I've got some HCT 245s. Yeah, getting desperate. I had a look. UT Source, you can request a price for these, but they're probably going to want to sell you like 100 or something. So that's unobtainium. That is unobtainium. You can only really get them from another board. We might have to use the other board to get this one working, and then yeah, it's going to be one out of the two. Now Stefan did say I could keep one of these if I can get them both working, but yeah, I think it's just going to be one working, and I'll just return them both to Stefan. I think it's not easy to test this. Obviously lots of these caps need reflowing and stuff now, because I've replaced them for 220 nanofarad. There's still a few on there actually. There's one, what is that? There's one here, 220. And there's one somewhere else, I can't see it now. Anyway, yeah, I'll swap those later. It's like, if that was adding a bit of resistance to the 5-volt rail, it's not going to be pulling it down enough. And you know what, when you get that kind of resistive thing on these, that's when they burn up like that one did. You know, they turn into resistors, they very soon thereafter set on fire. Yeah, so I'm going to get that off with some hot air and get a new one on. We'll get some capture tape just over that label. I could add some flux here to speed up the process, but just from experience of some of the other IC removals on here that we've done so far, they come off really, really easy, and there's a bit of flux already under there. I can see it now moving around from where it was presumably reflowed or swapped previously. There we go. So I'm just going to have a go at soldering that on. I've sort of anchored it in position, and I did reflow with hot air just to get it to sort of pull itself into a better position. But anyway, we've got some solder on the tip here, and I'm just going to just bob into making sure that's up to temperature actually. Yeah, just have a bit of a drag along here. You know, I'm not sure if that's floating off the board a little bit. Stuff like this I generally have to do off camera, so I know if you can see what I'm doing. Anyway, yeah, you saw that side. So I need to check for bridges there. But yeah, anyway, you get the idea. Right, after the insane amount of work I've done to this, I found something that might actually prove not related, but faulty anyway. This little inductor, it says R423. Sometimes these are used to filter, you know, between, I don't know, one power rail and another side of the board kind of thing. Sometimes they're also useful, those. Sometimes engineers design them in to allow you to be able to isolate power to a certain section. Not always, but yeah, in this case, I'm not sure what that feeds until I look at the schematics, but test on continuity, it's just an inductor. It should be like 0 ohms or something thereabouts, so maybe an ohm or two. Nothing. It's open circuit. Now this is the cap that fried. Did it take that out? I don't know. So it might have no relation to the audio issue. I mean, I've done everything on this board. There's nothing else to do now apart from consider that audio decompressing IC there, or the main MPEG decoder there. I think that separates the video, like say the video processes the video but separates the audio feeds into this, and then the lattice which supports everything. That's, I think, I was going to say an FPGA. I don't think it is. I think it's a CPLD. You've got to program it up. It could be an FPGA. I don't see what else it could be. There's no bad traces or anything on here. There's another one of those little things here, little ferrite. That's a short. There's one here on this corner. That's a short. So yeah, this is open circuit. So just to test, I'm just going to bridge that with a piece of wire. I've got some inductors, we can swap it out later. Let's just see if that makes any difference. But I mean, the location down here, maybe something's not getting a supply. That's a possibility. It could be that the DAC hasn't got proper supply. That would make the issue we are seeing here, create the issue we're seeing here. So you never know, maybe there's hope for this. I'll report back in a few minutes. Yeah, so I've just swapped my attention to the other board. Tidied up the 3 caps there, so those are straight now. Removed the balked cap there. Going to swap that in a sec. Just checking these ferrites. This one's open circuit. I can sort of show you that. See? Interesting, isn't it? These actually connect to the shield. I think that's all it does, is it joins up the ground to the shield. So it's really weird how those break. It could be impacts from, you know, prizing the shielding off, maybe. Right, so on this other one, I haven't checked the voltages yet, but I'm guessing we're missing one perhaps. I just measured around some of these caps here. Got short. So it could be another one of these big 220 nanofarads that's shorting somewhere. But yeah, these caps here are shorted. And compared to the other board, that isn't the case. You know, they shouldn't be. So yeah, this is definitely a capacitor shorting somewhere, or one of the main ICs. It could be one of the main ICs. It just throws up the stick a disc in screen, the normal, you know, stick your CD in. Those have all been swapped, it looks like. I suspect Stefan may have swapped the chips between this board and the other board, or may have swapped, you know, blitzed them on both of them. I don't know. If I measure there, yeah, we've got a very low resistance. I'll tell you the resistance. Yeah, 55 ohms. What we're doing on this one, isn't that one we swapped it, the ceramic there. So it's got to be one of these other ones. So I'm just going to measure around, see if I can get, see what, you know, the lowest resistance my meter will show me, and see if I can work out which one is the offending cap. On the other one, I've swapped all of those large 220 nanofarads. If you've got a CD32 FMV module, buy some decent quality 220 nanofarad caps and swap all of those large ones on there, because they're just going to fail. It's inevitable. This is exactly the problem, I think, between these two boards. On the other one, we've got a secondary fault. I'm hoping if I can get this one to boot, this one may spring to life. The only thing that's missing at the moment of this is the audio DAC. If we get that back on and find the audio's fine, then I'll take a risk and I'll swap this over to the other one. If that works and solves the problems, we've got both of them up and running, and I'll need to find a supplier of these somewhere. Right, so I removed a couple of caps on the underside here. We've still got the low resistance of like 50, roughly 55 ohms, I think. So I'm just going to remove that chip. I've got some flux around it. And what I may do is try it on the other board, actually. But we'll see first of all if the resistance disappears. If the resistance disappears, there's no point in trying it. Yeah, I'm going to come in from this angle down here, I think. There we go. Not putting any pressure there, it just made that noise. There we go, as it reached temperature. Just, yeah, lob that in there. So I'll let that cool down, see if the short has gone. Right, I removed the chip from the other board as well. I'm just going to test it without a chip, just to see what it does. Like, will it actually boot without the audio decompressor chip there? and then we'll try and put the warm one. It doesn't get hot, don't get me wrong, it doesn't get boiling. We'll stick that on here because we've still got the 55 ohm short on the other board, so it isn't that, and warm might just be one of these things. Sometimes you can get a chip that runs warm, sometimes they run cold. It's just one of those things, but it doesn't get hot. So let's just try this now and see what it does without that chip. I'm hoping it'll boot and we'll just be lacking audio. It's pretty sulky when it's on its side, the CD32, I have to admit, and it's because of the focus with the laser. You know, it kind of has a bit of a hard time trying to focus on the disc. If you get the lid sort of just right, it can start to read pretty well, but like right at the moment it's struggling to read. I might have to just put the lid down, I think. Yeah, it seems without that chip, it scans the disc a number of times when you first power it on. You know, like reads the disc, identifies what it is, and then it just freezes. And I'm guessing it's probably trying to initialize the MPEG stuff, and the MPEG chain there is trying to do something with the audio. And maybe because it's not receiving an interrupt or some sort of response, it just gets stuck in a loop. Yeah, I mean, I did just reseat it. I'll try and reseat it again just to make sure it is firmly connected, but that seems to be the response there. So the next thing here is to just hold the chip. See, just the smallest little touch there and I moved it. Right, I've anchored that in a couple of positions, so I'm now going to get the Amtech, get some flux around it, and do a bit of drag soldering. So let's get some flux around this. It's anchored a bit weird because it's anchored here and it's anchored up there. It's going to sound crazy, but I've got so much less space here than I did when I was on the floor. I'm not sure if that's in focus or not. I'll try and show you a single pass here, so I'll start in the middle somewhere. And just have a bit of a drag from the midpoint. Yeah, we got a bridge in the middle there, we got a bridge also on the end. Anyway, you get the idea. You've seen it all before, I've cut it on so many videos. Yeah, as you can see here, this is a better example of soldering the same kind of IC. I'm sorry the focus was out there. I was rushing for a number of reasons through this repair. So yeah, some of the camera work was not as good as it could have been. Right, just cleaning up now with some IPA. Yeah, it probably comes across in this video. I have been in a rush with this one. Just because we've got some of the stuff arriving. This has been sat around for blooming ages. And I want to get it back to Stefan. So I'm just going to clean it with a toothbrush and then inspect for bridges. So I'll just mop up now with a few cotton buds, and then I'll probably just blow the board down with a bit of hot air just for a few seconds, just to make sure there's nothing around there that could cause any issues. Right, well, we've got no shorts. I've connected it up. Let's just set that down so it reads a bit better. Switch it on. It's booting. Hey! That fixed it. So there we go. I thought it was that chip, but you know what, I tried everything I could to avoid replacing the darn thing. Sweet. So, yeah, that's one, hang on, one fixed. Yeah, those little chirrups like that is normal. I think it's because I knocked it. You hear that? Sometimes you get them just from a tap. Just tap the unit. Tap it again. Yeah. So that's the sort of problem you get. So, coming back to the one that isn't doing anything, I did drop Stefan a message to say, look, one of them I've sorted out now, we've got the sound on it, it's working, fantastic. The other one, I don't think I'm going to be able to repair, because obviously we're a sound chip down, you know, the MP2, MP1 decoded down, that's one thing, but also it's just black screening, it doesn't do anything. You can't get it to boot at all. And he was like, really kindly said, just keep them both, Chris. It's sad that we can't get one each, but just keep them both. So I said, look, well, I haven't given up yet, and I asked the question at that point. I know it's on both boards, these 5 chips here, the 7.4 series, I'll show you where they are in a minute, they've been reflowed. So did you reflow them? Did you replace them? Did you swap them out? What happened with them? And he says, oh no, I haven't touched them. I haven't done anything. I just recapped them, that's it. Now that gave me the positive thought that, hang on a minute, if he hasn't swapped those chips, then there's a chance it's going to be the data bus side. So that's where I'm going to start here. So up here you can see we've got UAB2, UAB1, UAB0. The U obviously is IC. You've got a U before all of the ICs on these things here. You know, it might be U1, U2, U0. In this case, UA, UB, whatever. And then the numbers. So we've got 3 for the address bus, and you kind of expect that because is it going to be 24 bits or something like that? Because these are 8 bits each. You got 8, 16. Yeah, it's going to be like a 24-bit almost address bus there. And then if you look at the top here, hopefully it's going to focus. You got RS is that, and then read/W, R/W, read write. So yeah, your read-write signals and your data strobe are going through there in order that the 68K can actually address hardware on this card. Yeah, and then the data bus side, 16-bit data bus here, 74HCT 245s, and those are 245s as well. That's all positive sounding to me because I'm thinking could be a balked data bus. You know, you get one bit that's failed on one of these 245s here, and suddenly you've not got bidirectional communication on one data bit to this board. I'm not sure what it communicates with directly. Probably this here, the UMPEG, is it? Which is a lattice CPLD. So this CPLD, just looking at this, it's doing some stuff to do with interrupts, ROM enable, so ROM address decoding there, config out, config in, I think, DSAC. So you've got, you know, bus protocol stuff here in terms of communicating with this as a memory mapped device. We've got CL450 control signals and things here. We've got the C64111 data strobe DS. So this is a middleman. It's a bit of glue logic. The CPLD is the interface into the MPEG chip, yeah, and it's doing some address decoding for different things for the ROM. It's doing interrupt handling and stuff for the different devices. We've got interrupt stuff here, look, for the audio chip. So yeah, it's glue. It's purely glue logic. We've got I don't know what these are here, some, I don't know, a bus of something going on there as well. We've got the pixel switch stuff there for the video, is that, so that it can, I don't know, maybe do some gen locking or something similar to that maybe. I'm not sure what these key things are here, key connections. Yeah, config in, so it's an auto config device, that's interesting. Now, I had vague recollections of seeing an article where someone created an adapter for a Zorro slot where you could plug one of these in, but I can't find it anywhere. I'm not sure if I imagined that or not, but I actually think that this could be made to be a proper auto config device and plugged into a 2000 or a 4000 or a 3000 or something. It might only work in late machines. It might need Zorro 3 because, you know, the CD32 is, you know, it was the 32-bit, you know, it's the step up. It was the same level as the 1200 and the 4000. So there could be some extra control signals, and the clocks may be different, and there could be some differences there. I mean, you can't stick that in a Zorro 2 slot, but nevertheless, it uses auto config. It's using the config in, config out, and stuff. And you know, I reckon you could make that work in a 4000. There's a connector here that says do not use programming connector. So there we go. That's how you program this CPLD here, the lattice. But the code I don't think is available for that. So yeah, unless someone like Stephen Leary was prepared to spend a week or a month or something, or however long it takes to reverse engineer that, and some of it you could probably just do by looking at the connections and things and doing a few logic captures. For someone intelligent like Stephen, or super intelligent I really should say, something like that might not be a problem. You know what, I think Stephen had actually planned to recreate the FMV module in an FPGA or CPLD. So you never know, watch this space, at some point in the future that might happen. The functionality may get put into something else. I mean, you could do the same thing in a Raspberry Pi, actually. Raspberry Pi is fast enough to do MPEG decoding. You could literally, you know, have an interface, capture the data that's been, you know, this is the thing, this is doing the magic of actually separating the packets and things, presumably, into audio and video, unless the actual MPEG chip is doing that. But if you can replicate that, you know, middleware functionality, and just decode using software on something like a Raspberry Pi, you could, in theory, have a Raspberry Pi do all of this. We've got two more 7.4 series up here. Now this is the one I swapped on the one with the sound issues earlier, because we've got some connections here to the 64111. There's 3 or 4 of those there. You know, signals that get buffered, and I'm not sure where they go. I mean, it's saying here data bus. So yeah, I'm not really sure which data bus is that. The Amiga side, it probably is. So the Amiga can determine the state of some of the interrupt levels or whatever on there. You know, control signals that come out of the audio decompressor. But I swapped that as part of trying to rule out the audio issues before we finally swapped out the only other thing it could have been, which is what I first thought it was, which was the L64111. And then also another register or something here, a 273, is that? Yeah, a 273. So yeah, could that cause this to not boot at all? Maybe. But I am going to start with the data bus here. We'll do DB 0 and then move on to DB1, see if that brings any life back. So yeah, just targeting data bus buffer 0. Can you see there's a bit of corrosion or something here? Yeah, some discoloration, and it smelt a little bit, and you can see it underneath the IC there. So you never know, I might actually ultrasonic this next, you never know, that might be the issue. So I'm just going to clean under that. I'll just use hot air to apply the chip we removed previously. You didn't see on the other one, when I was trying to get through to this, get to the bottom of the sound issues, I swapped this here, the STAT 1, just because it passes a couple of connections related to the MP2 audio decompressor chip. And you can see I got that back on this board. This is one with the glitch, and I got the DAC back on as well as any caps that I'd removed from this. I'm ignoring the 50 ohm thing just for the moment, and we'll just, I don't know, see where we get to by targeting some of these things here. So again, a little bit of guesswork, just because it's hard to work on these, it's hard to really scope anything. I mean, I could do now, I've managed to get the drive sort of working on its side. Might do that next, actually. Check the output on one here maybe, and see if it's actually accessing the one. But this is the one. After this went through the ultrasonic, and you know, we cleaned up all the caps, replaced the caps that would fail on here, the ceramics and things around the power sections and stuff. It still sort of, you know, looks at the disc a couple of times, and then just throws up the normal screen, the normal sticky disk in screen. So it's like it doesn't boot the MPEG side for whatever reason. So yeah, it's got to be something here, this or this. Everything else on here is kind of irrelevant. And yeah, I know that the voltages are okay. I can show you that in a minute, like a summary of what voltages to expect where on the board. There's a mark there. I think there's a bit of dirt or something around that. It's interesting how there's like some leakage or corrosion got under and around these. So it's anchored in the bottom right down here. I'm just going to get some solder on the tip. This isn't the tip I usually use with doing this sort of soldering. Yeah, I'm just going to bob into them because the surface area of the tip is so small. Yeah, drag soldering with it doesn't work so well. Anyway, you get the idea. That is one side done, and I don't see any bridges Oh my god, there we go. Follow your hunches. Fix this one. You know, we swapped 2 buffer chips. This is the other board, the 2 data bus ones. And it's working. But we obviously got the squeaky, clicky audio because I fitted that dodgy audio chip on that one. But the good news is both cards work. Yay! So I just need to try and source one of those chips. Let me see what I can find online. Right, so whilst that other one is on test, let's just deal with a few things. The first board, the RAM I put on here is 60 nanoseconds, and you know what, it didn't go on quite as straight as I would have liked, and we know that that wasn't the issue. I'm going to put the original RAM back on here. That came from my GVP actually, which was unrepairable, as you'll see in another video. I need to replace that bit of wire with a ferrite there. I need to replace the ferrite on the other one as well, because that's got a bit of wire there. Yeah, so here's the shell. If we set this into the shell, and I'm not sure which way round it goes, if we put it that way up, you'll see the 100 microfarad caps touch the edge, and the board is not flat on these mounts here. So yeah, those 100 microfarad caps are too big. Now, I was just looking through my spare electrolytics, and I've got, I don't know, about 20 of these 100 microfarad, 16 volts. And if you look at the height of these, they are about 2/3 the height of those ones, so they're going to be fine. These are about the same height as the 47s at the back, which are no higher, they're less than the ROM. So I'm just going to get the other iron powered up, use both irons, and just remove this strip of 100 microfarad caps here. And what I'm going to do is, Stefan originally said when I got them working, he was like, I'll just keep them both then. But now I've got both working, I'm going to keep the one with the pops, squeaks and crackles here. You know what? It's kind of therapeutic listening to the pops and squeaks and stuff. It kind of sounds like water. It's bizarre. I actually quite like it. I can actually sit here for a while watching this and listening to it and enjoying the pops and squeaks. Anyway, I'll try and source one of these. I did put a request in with UT Source to try and purchase 2. I might buy a few more if they say, you know, if they come back and say you've got to order 5 or something, and I don't know, if they're a reasonable price, like $10 each, I might just order 5 of them and keep one spare and sell the others or something like that. Yeah, anyway, I'm going to do the left side with the Antex and the right side with the Heiko. There we go, that's one. It's quite difficult to do this, not because using 2 hands is difficult, it's, there we go. There you go, it's getting both sides up to temperature.
It was about 4 p.m. when I returned to police.
That's all 6 of those removed. I'll just use a braid now to suck up the solder. Yeah, those caps are good as new, and I think the Panasonics or something, so I've just put them into my spares, so it's not really cost me anything in the way of capacitors here. As I say, we'll get this one working perfectly and ready to go back to Stefan, because then I can send it back to him with his SID card, which has been sat around since just after the SID card video. Right, I'll show you the first one here. That's one side. Just rotate that around a little bit. Yeah, just have to mute that. It's got Beach Boys music on it at the moment. I'm definitely going to get a copyright strike on that, even with all the water noise and fan noise. Yeah, I'm sorry this video has been really noisy. Anyway, you get the idea. So yeah, just a little reflow, and that's looking good as new. So I'll just do the same thing for the other 5. Right, that concludes the swap of the tall caps for short caps, so it should fit into the shell. As I say, there's a few final things to do to the first board here. I need to reflow that because that was just soldered on with hot air, and I'm just going to swap out one of the buffers here for one of the chips. The first one we removed on the other card, and the reason is just to check whether that chip was faulty, because I think it was just the second chip. And you may think, well, just put it in the bin, but you know what, they're starting to get to the point where they're a couple of pounds each, those HCT SOP chips, and they're starting to get lower in volume, so I don't like throwing away good 7.4 series SOP ICs that are proving harder to get. Alright, so some Captain tape around the things I want to protect there. Yeah, and we'll just heat this, and this is coming off again. And then I'll solder its original one back on, and drag solder the J legs, whatever they are there. It's an SOJ chip, isn't it? And you might be wondering why am I taking this back off? Well, A, it's not flat. B, it's a 60 nanoseconds part. It should have a 100 on there. There we go. And the 60s are harder to find than the 100s. I mean, I say they're hard to replace, but you know, they're not really. You could buy a SIM to contain these, but SIMs are now starting to get harder to find, aren't they? Really tight around here because of the electrolytic. Could argue we should have done that before fitting the replacement electrolytic, actually. Anyway, I'll just inspect, reflow anything that needs it, and then that's that done. And then we'll test it having replaced that, and it do need to reflow that as well in the same way, with some flux around it. And then finally I'll swap out one of these data buffers with the other one. Once that all works, then I'll just clean this up. I swapped out all of the 220 nanofarad caps on this because they seem to short on these. So there's just one more to do on this. There's one up there as well, actually there's two I think. I swapped that ferrite there with just a 1 ohm resistor. I don't have any ferrites, but it'll be fine. No, some stupid IPA. Yeah, so only one of the data buffers was balked. I put the original one, one of the original ones back on the first one I removed actually, and that's working fine. So pleased about that. It means I've only had to use one HCT245. So this is Stefan's board. Put it inside this shell, but you know what? The other shell is way better. It looks brand new. You can see that here. It's a nice silvery colour. This bit here is a bit warped plastic, so yeah, I'm going to heat with some hot air. Just see if we can massage that down. Not too high temperature, you'll melt it. But if we can just get that straight there, then I think I'm going to reseat or rehome Stefan's board inside this and then send it back to him, and then it's like good as new, isn't it? And then I'll just use this one here with the bits of corrosion for mine with the bodgy chip. Yeah, so the boards are technically the wrong way around at the moment because it says ESCO, and the board that's in that one is ESCO. So when it goes in here, it's going to be the other way. You know, it's going to have a different shell, but they're exactly the same board. They're just not the same shell. You know, one's like chromated, and one's got like a nice silvery chromy sort of finish to it. And of course, if this process goes wrong here, I'll be keeping this one and the other one will go to Stefan. So I'm just waiting for the hot air to come down. They always overshoot, so it's down to 130 degrees C. Yeah, or degrees communist, as Chris Edwards says. It always makes me laugh when he says that. Yeah, so yeah, it's pretty blooming bent, that plastic. Not sure how that's happened. Just on the end there, it's lifted up. Anyway, let's just heat gently here and just see if we can massage it. Yeah, it's going down already there. Yeah, so 130 degrees communist is just above boiling point. You could do with some glue under it, I think. I think what I would do here, this is plastic, just get a small piece of tape over there and stick a piece of tape over there, and then it'll just sort of hold it and feed it when it goes in and out the unit without it lifting up. But I mean, yeah, I'm going to do that, and then let Stefan decide if he wants to just carefully lift this and get some super glue under it, or epoxy or something. This is definitely the better shell though. Yeah, and I've just done that, stuck a piece of tape there to hold it, and it's yeah, a lot flatter, so it shouldn't catch inside the CD32. But if this was mine, if I was keeping this one, I would, I don't know, maybe heat it, pull it up a little bit, and then stick some really strong glue under that side and then put it back down. But yeah, that tape, that is going to do the job by the looks of things. So while Stefan's unit is on test, I've also got to stick this back down. It's the test and quality control thing, which went up here. So yeah, I'll just get some of that rubbery glue and stick this back on mine here. Thanks ever so much to Stefan for letting me keep this. I am chuffed to bits, even though I've got a sound issue with this, I am chuffed to bits with this. It's going to be a prized part of my collection. Yeah, and I just got some of that under there, and you can see I'm just sliding it around a wee bit, just because it was mostly in the centre, but straight away you can see that's stuck down totally flat, so pleased with that. I am just going to clean the top of the EEPROM here, because just where the label edge is here, it's a bit sticky. Yeah, so this side's nice and clean, that one now needs the same cleaning. So yeah, it's got a little bit of a dint in this one as well, so yeah, this is why I think I'd rather give Stefan the other one, because this one's not quite as good as it. There is quite a lot of dirt on there, so do you know what I think I'm going to do is just get some IPA and give that a bit of a scrub under there. Yeah, I can see the dirt coming off, that's looking good as new under that. You know what, this is the one I'm keeping. I'm going to carefully peel that off, I think. Is it going to come off? Yeah. Oh, there we go. But you can see it looks a bit faded there, and it's, I think it's just the glue. We give that a bit of a scrub. Yeah, it looks so much better. Look at that. Yeah, so a tiny bit of Maguire's Plast RX. And you can see in the light there, can you see? It looks a bit weird. So yeah, we'll just get a wee bit of that on there. Just checking to make sure no colour's coming off. And I don't think so, because it's one of these where it's, you know, it's assembled a certain way in terms of the printing on that. So you can't rub it off. That's it. Anyway, that will do for me. That's it. Just push it as forward as it can be. We'll reassemble this thing in a sec. There we go, with therapeutic clicks and squeaks. And I can show you how this is assembled just by dismantling this one. I need to, because there's a bit of rust there and it looks really dirty. So yeah, we'll take this one to pieces. I'll clean this up. I think what I'll probably do is just go stick these both into the ultrasonic cleaner, actually. Yeah, and then this just pulls out. So again, I'll send Stefan the better one of these back. You just got to sort of prise it out of this thing. That's it. Is that glue? Yeah. I spot the unlucky spider that climbed into the back of that. I need to get some more of this deoxit. This is my last tube. It's about £7 or £8 that, maybe even £9. Yeah, I did exactly the same thing with the one for Stefan. Just push it in and do a little bit of that. And you can go forwards and backwards quite nicely in these, unlike Neo Geo slots where you can get caught really easy and you've got to go quite slow. Yeah, so these are just hot melt glue. So we're just going to heat that in a minute because it's hanging on, look. Just sat there, and I'm going to have to replicate those on the other one because I'm not even sure that one's got any on it. I'm having to remelt this because those glue things actually sit on top of the plastic notch that pokes through the shield. That's how those work. It was glued on. Yeah. Yeah, I'm not sure you can see what I'm doing here. Yeah, I like that. And the narrow slots to the right hand side as you get that back into there. I'll try and get this in now without pulling that glue off. And then just put the 3 screws back into position. That's it. And then our card goes like that, I think. Right, let's try that again. That lid has been up, down, up and down, up and down about 100 times. That's why it's a good idea to stick bubble wrap over your window there. So, wrist strap on. This is the one that's going to go back to Stefan then. So I'll give the PCB a final clean here, but it's had new shorter 100 microfarad caps here. All of these 229 farads, there's one up there, look, have been swapped out. That was a smaller one. I ran out of the same physical size, but it's the same, you know, capacitance and voltage rating. Yeah, that one there. We had to fix a trace on this because this side of that cap there, I think that's the one, was broken off the board. I think that had happened in transit actually. I'm not sure. It looked like it happened in transit to me. Obviously this chip was swapped off the second board. It's now got its original RAM back in. I reflowed the DAC there because we swapped that out as well. That was one of the first things I did. We plugged 2 wires up there as well, just dealing with that bit of corrosion. And as I say, all of the other 220 nanofarad caps, you know, they're twice as wide as that cap there, for example, the quite wide ones. All of those have been swapped on that, because I'm convinced that that particular type of cap seems to fail. Oh, and one other thing, obviously, on this one here, I think it was this here, the ferrite was broken there. It wasn't like cracked or anything, just open circuit. So we fitted a 1 ohm resistor, and all it does is it joins you see the circle? That's ground, connects to the cam, just joins it up to the main ground line. So one of them being 1 ohm isn't an issue, because you've got 4 of these. There's one in each corner here. Yeah, and then I think that was glued down a little bit as well, just like on the other one. So yeah, that's pretty pristine, and obviously 100% fully functional, so that can go back to Stefan. And there we go, all back together. So Stefan did kindly say, you know, right at the start there, when only one of them was working, he's like, I'll just keep them both. Just keep them both. I was like, well, I'm determined to try and get them working. So, and at that point, you see, I'd kind of given up on the first one that wouldn't boot at all, because I assumed that he'd swapped all of the 7.4 series. And as things transpired, I don't think so. I think it was just a reflow. So yeah, that's what made me revisit and work out the issue with the second one. But the point is, he said, keep whichever one you want. And I was like, well, are you sure? And he's like, yeah, just keep whichever one you think is best. So I'm like, well, this is the best one, so I'll send you the best one. And I was like, no, keep whichever one you think's the best. So I'm like, well, I think this is the best one. I'd rather you have this one, because I know I would want to have this one. So yeah, I'm going to send him this one, because it's lovely, isn't it? It's almost good as new. The only thing I don't have, as I mentioned, is these screws here, but it clips together. You know, the top holds on, so I assume Stefan might have those screws. Yeah, so this is going to be the one I send back. Isn't it nice? It's lovely, and obviously fully functional. But I haven't really shown much in terms of removal and fitting things. I've skirted over so much because I've been in a rush, because I've got a few other things here. I've got some 4,000 boards lined up. I've got a 3,000 board that has arrived. Yeah, and I've just been a bit short of bench space. I'm sure that's probably been evident in this video. The knee cam has featured a few times here. Yeah, but just finishing up now, this board is perfect now in terms of you know, cleanliness and stuff. It's just this we need, and I did post on Twitter asking for you know, if anyone knew where to get one of these from, because even UT Source came back with, sorry, you know, the value is 0. We haven't got any. In other words, we can't get hold of them. And I contacted one of the place that was recommended from a chap on Twitter. That might be a follow-on if we can get hold of one of those. Yeah, we'll see what comes back, but I think these are just like not available anymore. They seem to have just gone. Stefan kindly did some searching on eBay for MPEG cards and things that may use the same chip, and he did find one, and I was super excited up until the point I realised what it was. And he'd found a card, and it was 199 euros, I think, with that chip on, and it was a Zorro 2 card for an Amiga 2000 or something. And I was like, well, yeah, and technically I could spend the €200 if I could save that up or something over the next few months, and then get one of those, take the chip off, fix this, and then I've got a Zorro 2 card that I then want to fix, and I'm back to posting on Twitter and stuff again. Does anyone know where to get one of these from so I can fix this Zorro 2 card? I think if it was a PC card, I wouldn't be bothered, to be honest. I mean, alright, PC cards, just as nice as Zorro cards, but for me, Zorro is always going to have the ace up its sleeve versus an ISA or, you know, PCI card. So yeah, I would be making the sacrilegious decision there of taking one of these off a PC card to fix Amiga card. I'd rather just find one of these as a second-hand unit or something. Anyway, let's see what happens over time. Lower profile caps here so that they fit inside the shield. And the shield ultimately is going to be one of the reasons why these die, because look how close it is. It's like the components like right up almost against the top there. They don't touch, but they ain't far off. Alright, there's got shield gaps in the shield in here, but that sort of thing is going to add to the demise of a product like this, isn't it? So one of the final things, because I haven't shown much of the soldering and soldering, can you see these beefy fat caps here? Yeah, these are one of the 220 nanofarads I haven't swapped. So we've got one there, and there's one here, and there may be one or two others. So I'm just going to, there's one there. So I'm just going to remove these. I'll show you me removing them, and I've got some tiny, tiny ones that are a wee bit short, but you know what? The right capacitance, the good quality, good manufacture, and the right voltage. So I'm just going to swap the remaining ones, because I think, as we've proven now, they die when they're in this area here, and on both boards these have failed when they're here. And it's the same one, 220 nanofarad, it's the same part, yeah. There could be a reason why, and it could be a voltage mismatch scenario. So we're back to what I talked about in the CD32 repair series there when I did my own, in that the power switch on the back of the CD32 switches two power rails. You've got 5 volts and you've got 12 volts. And if you get a switch bounce, you can end up with 5 volts and not 12 volts for a period of time until the contacts settle. If you've got a dirty switch, you can end up with 5 volts and no 12 volts. If you've got a dodgy power supply, you can end up with 5 volts and no 12 volts. What happens to various parts of the circuit there when you've not got 12 volts? I don't know. Is it possible you could have an issue? Well, I theorised that might be why the colour transistor died on my CD32, because that just happens to use the 12 volts on its collector, I think. So you had like a base voltage, you had an emitter, you had like 0 volts collector, or something like that. In that sort of scenario, what happens? I don't know. You've also got on here, and this complicates matters perhaps, you've got a 7805 here, you've got a 7805 here, both independently providing 5 volts to different areas of the circuit. What happens if you get one of these and not the other? What happens if the 12 volts is not there on one part of the circuit, the audio bit or the video bit, that needs 12 volts for something else? So yeah, maybe those are the sorts of things that cause this ceramic up here to just obliterate itself, because on the first one we looked at, there was a crack across it, and I measured and it wasn't short, but it had cracked. In other words, at some point it had short and blasted itself open. Now, because I'm using an ATX power supply, that's why on one of these, I forget which one it was, when I powered it on, I said, oh, I've just had a small fire kind of thing, I could smell some burning. And the cap on that was okay, that didn't have a crack, had suddenly just gone nuclear. Yeah. So yeah. Anyway, that was my reasoning for swapping all of these 220 nanofarads. And incidentally, I measured the ones on both circuits there for the the red, green, blue. You know, the ones removed for the colour issues. On the first board, I removed them accidentally because I got the boards mixed up. But I measured them, and there's nothing wrong with them. They measure the correct capacitance. There's no resistance. Yeah, when they're on there, you get weird colour issues. What you need is 1206s, yeah, 220 nanofarad 1206s. These are exactly the same spec, I think, slightly low voltage, 25 volts, but they aren't 1206s. So I can get away fitting one of these on here. I'm going to struggle with the blooming tweezers for sure. It's probably going to ping off now. So yeah, what you can do is use the, I can grab it with the tweezers. And this is the thing, the tweezers are going to melt now, aren't they? You want metal tweezers. Yeah, just heat that one pad. There we go, it's kind of on there, look. yeah, anyway, you get the idea. That's in place, but it's not straight, and because it's such a small cap, I need to just micro adjust this. This is where I'll use this tool, and this is why I just find it so much easier using this tool generally. Yeah, so I just get it into position. Hang on. And of course you can just reflow with a bit of hot air. In fact, I'll do that in a minute anyway, just so you can see it. So you'll be able to see, using a component that's perhaps not physically the right size, you can make it fit. So yeah, a bit of solder there as well. Let's just get the hot air on. Yeah, so hot air is on 400 degrees, and we'll just heat this, and it'll probably just sort of centralise itself a little bit better once it gets up to temperature. If you're going to heat things like this, generally, I'm going to hold this up, generally I'll have it a metal tin or something underneath it, just so that the heat doesn't transfer through to whatever's below. And in fact, it's kind of standing off there, so it'll be alright. Table might get a little bit warm. Yeah, and I'll just occasionally just tap it. There we go, it's moving around now. So yeah, it hasn't pulled itself into position. So do a couple of little taps like that. Just like Stefan's board, super clean and tidy. Data bus buffer's replaced. This was the faulty one. That's why this was not booming at all. Again, shorter capacitors installed here. All of these 220 nanofarad caps replaced here. 1206s, and they're the wide type. Normally you have to fit the narrow ones. Yeah, some shorter ones used in places like that, but it's the same, you know, the right components, sizes and stuff. That one. This was off to swap to the other board. Yeah, the cap there was okay. It was the one that had, it was the other board that had the wire there. Yeah, that one swapped out. Obviously this has now got the faulty audio chip on it. That cap was swapped out. That cap was swapped out. And there's that ferrite there that was replaced for a 1 ohm. As I say, it's just on the ground. We've got 3 other ones. So it's not that essential that it's not a ferrite. Yeah, we've got a cap there, a cap there, a cap there, and 1 or 2 others that I've lost track of. But anyway, you can see it's in excellent condition and everything looks really good. Maybe 1 or 2 of the caps aren't straight as they could be. Let's hold that on the shield. We'll check the 7805 here first. Let's just check the first pin. So that's the output, 5.17 volts, which is what you'd expect. It's a 5-volt regulator, and the input, being very careful, is 9 volts. 9 volts? That's weird. There should be 12 on here. How have we got 9 going in? That may be normal. And then we've got a 7805 over here, this thing. So if we measure, I think, one of these caps here. That's 12 volts. So 12 volts goes into this one here. Let's just carefully, I'm just going to have to just lean on this, carefully just try probe pins around that. There you go, 5 volts on its, this first pin here. Just checking the other pins anyway. It's interesting how a 7805's in an 8-pin package there. I'm not quite sure what they were thinking about when they came up with that. Yeah, so the output is that top pin there, for sure, on that corner pin. Bottom left, as it's facing us. So our 2 5-volt supplies are there. I'm just testing to see how hot that is. It's interesting, isn't it, how that's got 9 volts there. I need to look at the schematics to work that out. There is a diode down here. Maybe it's got a diode drop or something. Let's just measure carefully across that diode. 5 volts one side. Now that's between the 5 volt and 9 volts. How have we got 9 volts? I do need to check that. Anyway, so you've seen the general thing. Let's just check some of these caps here as well. So you've got 5 volts there. These are coupling caps, I think. That one down there. 12 volts on that. This one here. 4.62. Now that is the 5 volts from my main power supply into the CD32. So at this point in time, you can see I've got voltage drop there. I should have 5 volts there. My ATX power supply through the horrible power switch cable and all the rest of it is only giving me 4.62 volts. That isn't the issue with the audio. I ruled that out earlier. But yeah, anyway, you can see though that there's a number of different 5 volt supplies. You've got the one from the CD32, the one from that regulator, the one from that regulator, three different 5-volt supplies. And I presume it's going to be like the audio and stuff's on its own, the video's on its own, and the rest of the logic comes from the main 5-volt rail there, which is 4.6 volts at the moment. And that's to avoid noise. You know, if you had everything powered by the same 5-volt rail with the same ground, you get problems. You know, you can get little glitches and things like that. So down here, it's going to be the main 5-volt rail probably. Yeah, 4.62. Over here, again, it's going to be main 5-volt rail probably, 4.62. And the 7.4 series here is going to be the main 5-volt rail. So the upmost pin is that corner one there, yeah, 4.62. I don't know where the VCC pin is on this, but I'm guessing that's going to be the same. And I think this is going to be taking it from one of these other areas. It might not be, that might be from the same place as this. Anyway, you get the idea. It's probably a case of the DAC's got a 5-volt supply and the stuff here's got a different 5-volt supply. Maybe all this logic here is all on the main 5 volts. And just looking at the schematics, you can see here we've got the audio DAC at the top, so that's got its own 5-volt rail. And then scrolling down, we can see the video DAC also has its own 5-volt rail. And just looking at that, you can see there's a resistor or something to the left-hand side, and I suspect there's some voltage drop or something occurring from there. I can't quite see what's the left hand side without joining all the pages up, but I suspect that 9 volts is correct. And you know what? This is a bit of justification on swapping all of those blooming ceramics. These are the ones we just took off this board, and the board was working, yeah? And I used literally hardly any heat to remove them, dead short. Yeah, that was showing 1 ohm. These ones here, no resistance so far, but you know, one of the ones we just took off as a precaution there is showing 1 ohm. So this is exactly why, if you've got one of these and you don't swap out the 220 nanofarad ceramics, all of them, not just the ones on the RGB, you're waiting for some of the failure. So just putting back on resistance, I'll tell you what it says. Yeah, nothing on that one. And I've got some of the other ones we took off earlier as well. A lot of these have just gone straight in the bin, but I did keep, I don't know, another 10 or so. Again, no resistance showing on that one either. So we did find a shorted one on that. I'm so glad I swapped those. Yeah, and there's some of the other ones that I took off, so I'll test those and I'll report back. Yep, and here's another one. Now this isn't a short, but hang on, it's a resistor, 11.6k. So yeah, so a multimeter on my knee. Here's another one, almost 3k. Look. So it was only had on 3 or 4 that were a short there in total, and maybe 5 if you include the 2 on the power sides on both of them that had blown themselves open. But those were just from generally around the board. So yeah, those 220 nanofarad swapped them all. And you'll remember that this is the board that had 50 ohms across one of the supply rails. I think it was this one here actually. And that's now gone, and it's exactly the same as the other board now, I think. Yeah, it's like a couple of K. So there you go. Just as part of that final recap there, you know, not really recap, swapping out the 220 nanofarads, we've got the resistance back down, but this board was working as it was. You know, you got a 1 ohm resistor there, it's just going to be drawing a lot of power. You know, if you had a thermal cam, you'd be able to see it getting hot probably. At some point it probably would have shorted and burnt the trace up, certainly with an ATX power supply. Yeah, that's it. Yeah, there we go. So let's just get the lid back on. I left this print on here, actually improved it. It was worn away a fair bit. So yeah, I just used magnification, a black mark, and carefully just filled in the little gaps and stuff. So, because it's a bit of history. And I asked Stefan about this, and he was saying I think it means received from WL, is that, or WC person. 22nd of the 2nd, 1994. Not sure what the ESCO means there, but yeah, it's a piece of history, so that's why I redid that slightly, just so that it's not worn away as it was. Yeah, this shell is a little bit battered compared to the one that I'll be sending back to Stefan, but it clips together. You can see, you know, you can't pull it apart, so even though I'm missing the screws around the sides here, no big deal. So very, very pleased. And you know what, it doesn't look too bad. It's been polished up there. It doesn't look bad. Yeah, there's a few little marks and things, but this is why I opted to keep this one. It's not perfect, but it's my not perfect FMV module. There we go. there we go, and these are going back to Stefan. So I do hope you found the video interesting. Please like, share, subscribe. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.